Hello everyone, welcome to another video. This is the first video of the series on LeetCode, and today we're going to talk about LeetCode 141. So on the left side we can see the problem, and on the right side we're gonna go through the problem, find out ideas and ways to approach it. So let's go through the problem first. So the problem basically tells us to find a linked list cycle, and they're going to give us two things basically. The first one being the head of the linked list and a pause. Pause is not something that we can work with, so this is the only thing that we need to look into and find if there's a cycle within the linked list. So let's try to look into the example that they have given here. So it's 3, then 2, then 0, then -4. So these are each nodes or elements within that linked list, and when we're going through traversing the linked list, we go through 1, 2, 3, 4, and ideally it should stop here, right? Because there shouldn't be anything else on the list. But due to the design of the linked list, when we reach -4, it goes back to 2 again. Goes back to 2 again. So we need to find out if the linked list itself has a cycle, meaning that 4, when we go to -4, comes back to 2 and then goes to 0, goes to -4, and this goes on like a loop. All right. So how do we approach this problem? And the initial thought process is, okay, let's do a while loop that can go through the linked list. And if we come across the same value again, so we go to 3, 2, -4, and we find the same value again, that means this thing has a duplicate value. That means we are traversing the same values again, which means it is a cycle. However, the problem with that is, if we are storing values, let's say we are storing values in an array or within another list, it has to continuously, that array is continuously increasing, or the list, whatever you prefer, is continuously increasing, right? And every time, let's say you're on -4, you have to check, hey, is -4 within that array or not, right? Now, this seems simple for smaller numbers, so like for smaller counts or smaller lists. However, it's not possible or doesn't make sense when there are 1,000 values, right? Yes, it might work. Definitely it would. But the goal of LeetCode is to have the best performance and with the least amount of time. And this does not cut it, right? So what is the other solution? How do we approach this problem with the same concept that we are checking the values if we encountered the same value or not? So there are two ways to solve this. The first one is the hare tortoise problem, or the algorithm, which you can Google to find out. It's pretty simple. There are two pointers. One is a slow pointer, and another one is a fast pointer. So the slow one goes by 1, and the fast one goes by 2. So increases by 2. And the other one is, and this is the solution that we are going to talk about, because this is the one I felt that this is the most understandable for most people. But there's a catch here. It changes the values within the linked list. Now, if you look into the problem, nowhere here does it say you cannot change the values. You cannot change the values. There is a problem like this, same problem, but the requirement is you cannot change the values. So we are going to talk about the hare tortoise algorithm for that problem, which would be the next video, hopefully. And but now we're going to talk about this one. So we are going to change the values of the linked list. Okay, so how are we going to do it? So let's look into an example. Let's look into the same thing that the problem states. So 3, 2, 0, -4, and this -4 then loops back to 2. Okay. Okay. So what we are going to do is we're going to loop through the linked list. So initially we get 3. Okay. Cool. Then we replace. So initially we get 3. Then we check, is 3 a value that we have encountered initially? So as we are trying to solve this problem using Python, so the variables can have any type, right? So a can have, let's say a is a variable, a can have numbers or strings or anything like that. This is how Python works. But for other languages, let's say like Java, you have to put, let's say you're putting the value, let's say we have the variable called val, and you're storing whatever value you got from the linked list by traversing. So let's say it's 3. For Python, you can let's say change value of 3 to a. Okay, but for Java, you have to keep the same type, so you have to keep it an integer. Now, one of the constraints says that the number of nodes in the list, blah blah blah, it has to be from minus 10 to the power 5 to 10 to the power minus 10 to the power 5 to positive 10 to the power 5. So you have to replace it with a value that is above or below that range. All right. So let's look at the Python way, because that's easier to understand. Okay. So we got the value 3. We are going to check. We are going to basically check if this value. So let's say the variable is called val is equal to let's say for p for present, and this is a string. Okay. If the value that we got, is it equal to p? If it is, then that means this is the value that we got before, and that means there is a loop. So for our case, the linked list values still look like this, and 3 does not match with p. So what we're going to do is we are going to replace 3 with the value p. Okay, so now the linked list looks like this, p20 minus 4. Cool. Now, next up we go to the next value. So val is 2 now. We again check is 2 equal to p. It's not, so we change the value again. So p0 minus 4, and you get the point, right? So we traverse and make all the values p. All right, cool. So this is now what the linked list looks like, and we still haven't traversed. We still haven't triggered the loop yet. So if you look into the old values, this was minus 4, right? And the loop was minus 4 goes back to the first index, which was initially 2. Okay. Now, what our loop would do is it again comes here, we change the value and goes to the next. So the next is basically this one, right? And it says, hey, val equals to p is val equal p. Yes, that means we are in a loop because we are seeing the same value again. So this is the solution that we are going to talk about, or we are going to see the code after this. But this is the most easiest solution and one that is most understandable without going to complex algorithms. Basically changing or replacing the values with something that we can look into later. So p, and p, then when 4 loops back to whatever index the problem is on. For example, the example says in the LeetCode problem says the position is 1, and for our case this is position 0, 1, 2, 3. So after reaching index 3, it goes back to 1, and our problem or our solution basically goes back to p again, checks if this is the same value that we are checking against. That means there is a loop. Now let's look into the solution. Okay, so on the left side you can see the solution is accepted, and for runtime it beats 55.06%, and for the memory it's 97.94%. Yes, it's not the best, but let's just go through the solution to understand how we approached the problem. Okay, so this is the part that's already given to us, and first we need to check, hey, if the list that they provided as a test case, is the list empty or not? Because if it's empty, we don't need to go through all of this code, right? We don't need to look into it. Nothing needs to be done. No point in using up resources. So if it's empty, we are returning false. That means there is no loop. Okay, moving on. All right, so the next test case we are going to talk about is, let's say the linked list has only one value, and it doesn't point to itself or anything else. All right, so it doesn't point to itself or anything else. In such cases, that means there is no loop. All right, so these two cases ensure we don't need to go through the whole set of code. Okay, so remember, as I mentioned in the initial problem, so 3, 2, 0, minus 4, we are replacing the values. So here, rather than saying p, I'm saying the value is, or the replacement value is checked. So I'm replacing the head, which is for our case 3 is the head. We're replacing 3 with checked. All right, and moving our pointer to the next one. Now we are going into the loop. So while head.next is not none, so we need to understand, hey, is the next value present or not? So is there a node after 3 or not? So if it is, go there, check the value. So see here we're checking if the value of the pointer, so in our case the pointer is basically the variable called head. We're basically checking if the pointer's value is checked or not, checked the string. And if it is, that means there is a loop, so we return true, else we replace the value. So for the next one, for our case, it's not, so we are replacing the value with the string checked, and this is how we traverse the whole linked list. If after traversing, let's say there isn't any loop, so basically 4 doesn't point back to 2, so it doesn't point back to 2, it just ends here. So after this, so head dot next, my bad, head dot next is basically none. Then it's done. That means there was no loop and we return false. So now let's look into, so I submitted the code again, and let's look into some of the test cases that I went through. So 32041, the example that was present here in the LeetCode problem, and the head position of the loop basically starts from, points back to index number 1, and in this case the output is true and the expectation was also true. And for other cases like these, which does not point back to anything, which is 0, sorry, it points back to 0 again, so it points back to the first index, and it, in this case, it also found out that there is a loop. And for the first one, remember that we considered that there might be cases where there's just one value in the list and it doesn't point back to anything, so the pause is -1, referring to it does not have a cycle, and our system or our code identifies it properly. That's about it for this solution. Thank you, and let me know if I can help you with anything else again.